This is Shreya Chinamilli, a student of VIT Vellore, registration number 20BCE0816. So now this is a part of my physics assignment.
I'm going to give a brief introduction to nanotechnology and Moore's law. Let's first know what nano actually means. In Greek language, the word nano means very small. That is, it generally refers to 1 billionth of something. It might be a meter. 1 nanometer is equal to 10 power minus 9 meters. Nanoscale is the smallest measurement that you can see on a ruler. For example, a human fingernail grows 1 nanometer every second. This change is very rare to observe by our human eye and we can't generally notice it. Also, a human hair grows 5 nanometers every second. As you can see here, this is one human strand and it keeps growing 5 nanometers every second. Nanometer scale ranges from 1 nanometer to 100 nanometers. Nanotechnology. What is nanotechnology? Most of you think that nanoscience and nanotechnology means the same. But let me tell you, nanoscience means exploring and studying the properties of nanoscale, whereas nanotechnology is the art and science of manipulating atoms, molecules to create new systems, materials, and devices. It also means applying unique properties of nanoscale to technology. Properties of nanomaterials. Nanomaterials have generally have very unique properties and which have properties better than the larger particles. Some of them include they are more chemically reactive than larger particles. Also, when we have metals in nanophase, they absorb hydrogen. This property of nanomaterials can be used for hydrogen storage in metals. The properties of nanomaterials of magnetic materials are changed so that they are behaving as other kind of magnetic materials. For example, when we consider three metals like cobalt, nickel, and iron, cobalt, nickel, and iron are in ferromagnetic stage when they are in bulk state, but they are changed into super paramagnetic in nanophase. Applications of nanomaterials. Nanomaterials have got wide range of applications in every field of science and all like biology, physics, chemistry, material sciences, polymer sciences, electronics, biotech, chemical, and whatnot. So, it nanotechnology is interdisciplinary and impacts many applications. So here comes the question. So, where does nanotechnology actually fit? On one hand, it is not physics, biology, chemistry, and on the other hand, it's all of them. One of the most useful application of nanomaterials is the Rotas effect. So, what does Rotas effect mean? The Rotas effect refers to self-cleaning properties that are a result of hydrophobicity as exhibited by the use of Rotas fry. Dirt particles are picked up by water droplets due to micro and nanoscopic architecture on the surface, which minimizes droplets' adhesion to the surface. Here you can see when water droplets fall on the rotor's reef, they do not get attached to the rotor's reef. Instead, they go far, they sprinkle away without getting attaching. This is an example of Rotas effect. Rotas effect is used in nano t-shirts, also known as hydrophobic t-shirts. As you can see, the person wearing the blue shirt here is wearing a nano t-shirt, and the one wearing the white shirt is normal t-shirt. So when we throw a bucket of black ink on them, the blue guy remains shirt remains the same without getting dirty, whereas the white shirt is all over the full ink. So here we can know nano t-shirts, also known as hydrophobic t-shirts, is very good use. But the only thing is they are very costly and cannot be afforded by normal people. Nanostructures and devices. Nanostructures and devices can be accomplished by two approaches, the bottom top approach and the top down approach. What is Bottom-top approach. It is an approach where small building blocks are made into larger blocks. For example, chemical synthesis, laser trapping, self-assembling, collider aggregation, etc. All these come under bottom-top approach. As you can see, in the bottom-top approach, molecular precursors are converted into nanostructures and then they are converted into bulk materials. Top-down approach. What is top-down approach? In this approach, larger blocks are converted into smaller features. For example, film deposition and growth, nano imprint, lithography, etching, mechanical polishing, etc. All these use top-down approach. In top-down approach, by fragmentation, bulk molecules are converted into nanostructures, and nanostructures are later converted into molecular precursors like atoms. Moore's law. What is Moore's law? Moore's law states that the number of transistors on a microchip doubles about every 2 years, that is 24 months, though the cost of computers is halved. In 1965, Gordon E. Moore, the co-founder of Intel, made this observation that became Moore's law. The thing which you have to keep in your mind is Moore's law is neither scientific law or nor any law of nature. Moore's law has been the name given to everything that changed exponentially. Hope you enjoyed my presentation. Thank you.